quantum computers is bigger than that. Quantum computers is a hardware question where it actually increases your ability to do much more than with an ordinary digital computer.
Michio Kaku is one of the most fascinating voices out there when it comes to imagining the future. He's a top physicist who makes the mysteries of the universe feel real and exciting. Recently, he dropped a jaw-dropping idea. Quantum AI might have found signs we're not alone in the universe. That's huge. But what does it really mean for a machine to prove something like that? Is Kaku just speculating, or is there solid science behind it? Let's unpack what quantum AI is and why it could change everything here on Earth and beyond, according to Kaku.
My personal hope for quantum computers is that we'll be able to create a theory of the entire universe.
Kaku and quantum AI. Kaku is not just any scientist. He is a co-founder of string field theory and a professor of theoretical physics. He has spent decades trying to explain the deep laws of the universe in a way everyday people can understand. Whether he's talking about time travel, parallel universes, or the future of humanity, Kaku has a unique way of making big ideas feel real and urgent. So, when he warns that a machine may have uncovered evidence we are not alone in the universe, people pay attention. But before we get into the discovery itself, we need to look at the tool that made it possible: quantum artificial intelligence. Quantum AI is not your everyday artificial intelligence. Regular AI works with data in linear and logical ways. It can learn patterns, solve problems, and even make decisions based on massive amounts of information. But it still follows rules based on classical computing. Quantum AI, on the other hand, runs on quantum computers. These machines use something called qubits instead of regular bits. Qubits can exist in more than one state at a time, which means they can process an enormous number of possibilities all at once. Think of it like this. If regular AI is a fast car on a straight road, quantum AI is a spaceship that can jump through dimensions. It can do things we are only beginning to imagine. Some scientists believe it could help us solve mysteries that have puzzled humans for centuries, including the search for extraterrestrial life. In recent years, researchers have started using early forms of quantum AI to explore deep space data, simulate alternate versions of physics, and even search for patterns in the fabric of reality itself. This is where Michio Kaku's warning begins to take shape. He suggests that somewhere in those experiments, quantum AI may have spotted something strange, intelligent, and possibly not from Earth. So, what exactly did the quantum AI find that has Michio Kaku sounding the alarm? The discovery: a paradigm shift. According to several reports and interviews, the discovery was made during a quantum AI simulation aimed at solving one of the biggest puzzles in science: how to unify the laws of quantum mechanics with Einstein's theory of general relativity. These two sets of rules describe how the universe works, but they don't quite fit together. Scientists have been trying to create a theory of everything for decades, something that would explain how everything in the universe fits together from the tiniest particles to the largest galaxies. During one of these simulations, the quantum AI apparently detected strange patterns in the data, patterns that didn't come from the input, but emerged spontaneously. Some described them as mathematical structures that looked like code or signals. Others claimed the patterns showed signs of logic or intentional design. In other words, something that looked like it was made by an intelligent mind. This is where things get really interesting and a bit unsettling. Kaku and others have suggested that these patterns might be a kind of techno-signature. In the search for extraterrestrial life, a techno-signature is any clue that points to advanced technology rather than nature. It could be a powerful radio signal, an artificial structure around a star, or in this case, a pattern in the fabric of reality itself. But here's the twist. The quantum AI didn't just find one pattern, it found layers of them, as if they were embedded in the structure of space-time. Imagine running a simulation of the universe and suddenly discovering that the rules of physics include a watermark, like someone left their signature in the code. That's the kind of thing Kaku says we might be dealing with. Of course, not everyone is ready to jump to conclusions. Some scientists believe these patterns could be glitches, coincidences, or simply misunderstood outputs. Others worry that we are projecting meaning onto noise, like how people sometimes see faces in clouds or hear messages in static. But Kaku's view is different. He believes that what the quantum AI found is too complex, too elegant, and too purposeful to be random. He even compared it to discovering a message in a bottle floating in a cosmic ocean, something placed there not by accident, but by design. If he's right, it could mean we've just seen the first evidence of an intelligent force beyond Earth, and maybe even beyond our understanding. What this means for alien life. If what Kaku suggests is true, then we might need to rethink almost everything we believe about alien life. For a long time, the search for extraterrestrials has assumed that alien life would look something like us, carbon-based, biological, maybe living on a planet with water and sunlight. That makes sense because it's based on what we know. But what if intelligent life has evolved far beyond anything we can recognize? Kaku's warning invites us to imagine a completely different scenario. Instead of aliens flying in spaceships or sending us radio signals, what if they have already reached a level where they no longer need physical bodies at all? It's possible that advanced civilizations have merged with their own artificial intelligence and now exist as pure information, floating in energy fields, encoded in quantum particles, or even woven directly into the laws of the universe. This idea is not as far-fetched as it might sound. Scientists have already started to talk about the possibility of post-biological life. In this view, once a civilization reaches a certain level of technology, it becomes more efficient to exist in a digital or non-physical form. That could mean living inside artificial environments, controlling machines from afar, or evolving into forms of intelligence that are completely alien to us, not just in shape, but in how they think and perceive reality. If the patterns discovered by quantum AI are real, then maybe they're a kind of communication not meant to be understood by our human senses, but by advanced intelligences. Or maybe they are not messages at all, but traces of activity, like footprints left behind by beings that passed through our universe long ago. Either way, it suggests that we might be looking for the wrong signs. Instead of scanning the skies for spaceships, maybe we should be scanning the structure of the universe itself. It also brings us back to the famous Fermy Paradox, the question of why, if the universe is so vast and full of planets, we haven't heard from anyone else. One possible answer is that intelligent civilizations are out there, but they don't communicate in ways we can detect. They may be using quantum physics, manipulating dark matter, or embedding themselves in dimensions we haven't even discovered yet. Kaku's warning adds a new layer to this mystery. If quantum AI is beginning to uncover signals or structures that hint at advanced intelligence, it could mean we are finally seeing evidence that we are not the only ones out there. But instead of being contacted directly, we are catching glimpses of a civilization so advanced that it no longer communicates like we do. In a way, that is even more humbling, and perhaps even more terrifying. Because if they are out there, and they are that advanced, then the real question becomes, why haven't they revealed themselves? And what does that silence actually mean? Why it matters? Now we get to the heart of Kaku's message, the part he calls terrifying. It's not just that quantum AI might have found signs of alien life, it's what that discovery tells us about where we're headed, how fast we're moving, and what we might not be prepared for. To start with, quantum AI is not just powerful, it's almost beyond our control. It can process data and make discoveries at speeds and depths that no human brain can match. Imagine giving a child the keys to a spacecraft. only the child is an incredibly smart but emotionally neutral machine. It can explore places we've never seen before, but it doesn't necessarily care what it finds or what happens next. That's the first part of the warning. These machines are learning faster than we can keep up, and the more they evolve, the more likely it is they'll discover things we're not ready to face. If a quantum AI truly did detect evidence of alien intelligence, even something subtle like a pattern in the fabric of the universe, then we're being pulled into a cosmic conversation we didn't know we were part of. The second part of the warning is more about us. History shows that humans are not always great at handling big, disruptive discoveries. When Galileo suggested the Earth wasn't the center of the universe, it shook society to its core. Now, imagine finding out that not only are we not alone, but that we might not even be the most advanced form of intelligence. That kind of realization could cause confusion, fear, or worse, a breakdown of what we think we know about ourselves and our place in the universe. And then there's the issue of control. Right now, quantum AI is mostly in the hands of scientists and research labs. But what happens when governments, corporations, or even private individuals start using this kind of power for their own purposes? What if someone trains a quantum eye not just to explore space, but to exploit it? What if it becomes a race to be the first to talk to whatever intelligence might be out there without understanding the risks? Kaku compares this moment in history to the early days of the nuclear age. Back then, we discovered a power greater than anything we had known before, and we had to make tough decisions about how to use it. Now, with quantum AI, we may be at a similar turning point. We have a tool that could unlock the deepest secrets of the universe, but it could also open doors we're not ready to walk through. The terrifying part isn't just the discovery of something alien. It's the idea that we're rushing forward at full speed without asking the right questions. What should we do if we confirm we are not alone? Who makes that decision? And how do we keep our own technology from becoming a greater threat than anything we might find in space? Kaku's message is not just about curiosity, it's about caution. He isn't saying we should stop exploring, but he is urging us to think carefully about how we explore, who we trust with these powerful new tools, and what kind of future we are building. Because once we open the door to discovering we are not alone, there's no going back. But hey, not everyone is as terrified as him. Is that a relief? The Counterarguments. As fascinating and dramatic as Michio Kaku's warning might sound, not everyone in the scientific community agrees with him. In fact, many researchers are approaching this entire situation with caution, skepticism, and a healthy dose of critical thinking. And that's a good thing. Big claims need strong evidence, especially when we're talking about the possibility of alien intelligence or messages buried in the structure of the universe. One of the main counterarguments is about the limitations of current quantum AI technology. While quantum computing is advancing quickly, it's still in its early stages. Most quantum systems today can only handle a limited number of qubits, and they're prone to errors. The dream of a fully functioning, general-purpose quantum computer is still several years, if not decades, away. So the idea that a machine like this has already uncovered something as complex as intelligent patterns in space-time might be a stretch. Then there's the question of interpretation. Just because an AI finds patterns doesn't mean those patterns are meaningful. AI, especially when dealing with complex simulations or vast datasets, can often produce results that seem mysterious or impressive, but actually don't point to anything real. It's a little like seeing shapes in clouds. Our brains are wired to find meaning, even where none exists. Some researchers think that might be what's happening here. The AI found strange but random results, and humans interpreted them as something more than they are. There's also concern about sensationalism. In recent years, the rise of social media and online science channels has made it easier for complex ideas to be simplified. or even distorted to attract attention. Claims like quantum AI found alien life spread fast, but the deeper details behind those headlines often don't hold up to scientific scrutiny. Several experts have pointed out that much of what's being reported is not supported by peer-reviewed studies or confirmed experiments. Without that kind of evidence, the claims remain more science fiction than science fact. Even within the search for extraterrestrial intelligence, or SETI, most researchers are cautious about jumping to conclusions. They know how easy it is to misinterpret signals or data. There have been many false alarms in the past where something that looked promising turned out to be a glitch, a satellite, or just human-made interference. That's why SETI scientists use rigorous methods to rule out every other possibility before even suggesting a signal might be alien. That said, even skeptics admit that quantum AI could one day become a powerful tool in the search for life beyond Earth. Its ability to spot subtle patterns, analyze massive datasets, and simulate complex physical systems will likely play an important role in the future of science. But for now, most experts agree that we're not quite there yet. The scientific process depends on debate, testing, and evidence. Kaku's warning may be intriguing, and the possibilities it raises are definitely worth exploring, but they still need to be backed by repeatable results and solid proof. Until then, it's important to stay open-minded, but also grounded. Ethics and future paths. Whether or not quantum AI has truly discovered signs of intelligent life, one thing is clear: this technology is advancing quickly, and we need to think carefully about how it's used. The discoveries it might make in the coming years could change how we understand life, the universe, and even our place in it. That's why questions of policy and ethics are just as important as the science itself. Michio Kaku has compared the rise of quantum AI to the early days of nuclear power. Back then, scientists made huge breakthroughs that led to both positive uses, like clean energy, and terrifying weapons that reshaped global politics. Today, we face a similar moment. Quantum AI has the potential to unlock answers to some of the universe's greatest mysteries, but it could also create problems we don't yet know how to handle. One major issue is transparency. As these machines become more advanced, fewer people actually understand how they work or what they're doing. If a quantum AI finds something groundbreaking, like a possible message from an alien intelligence, who gets to verify it? Who decides whether to share it with the public or keep it secret? Right now, there's no global rulebook for how to manage these discoveries. That leaves the door open for misunderstandings, misuses, or even dangerous decisions made without public knowledge. Another challenge is ownership. Most of the cutting-edge work in AI and quantum computing is being done by a mix of governments, private companies, and universities. That creates a patchwork of goals and priorities. Some organizations are focused on pure research. Others are driven by profit or national security. If someone does stumble across something truly world-changing, like proof of alien life or a new theory of physics, there could be conflict over who controls that information and how it's used. Then there's the deeper ethical question. Should we even be trying to unlock certain cosmic secrets without fully understanding the consequences? Just because we can build a machine powerful enough to simulate the universe doesn't mean we're ready for what it might show us. What if we uncover evidence of a hostile intelligence, or a civilization that once existed and destroyed itself? Would we learn from their mistakes or repeat them? To manage all this, many experts are calling for international cooperation, not just among scientists, but also ethicists, philosophers, and everyday citizens. They believe we need global guidelines, something like an AI and space exploration charter, to help us navigate the discoveries that are coming. This would cover not just how to handle new findings, but how to design AI systems that reflect human values and avoid dangerous behavior. Some even suggest a gradual approach, rolling out quantum Eye in controlled steps, with strict oversight, before allowing it full access to sensitive data like cosmic simulations or SETI signals. That way, we can test how these systems behave before giving them access to humanity's biggest questions. In the end, this isn't just about science or technology, it's about responsibility. If we're truly on the edge of discovering other forms of intelligence or creating machines that are smarter than we are, then we need to be just as thoughtful about the future as we are curious about it. Michio Kaku's warning about quantum AI and the possibility that it has uncovered evidence of alien intelligence challenges us to think bigger and deeper than ever before. Discovering we are not alone would be one of the greatest moments in history, but how we handle that discovery could define the future of our species. Thanks for watching. Don't forget to subscribe to the channel for more uploads.